I'm going to do 11B and C in this video. I think I did 11A in another video, or at least one really similar to it. And the video for 10 and 11A kind of have a lot of other examples from an old study guide that I did at some point. But anyway, so I want to find the tan of 7 pi over 3. You can see over here on the right, I have my chart, and I have it's my all students take calc, or however else you can remember it, which tells me which are positive. So for example, in this quadrant, sine's positive, tan's positive, cosine's positive, all three of them are positive. Anyway, I first need to start by figuring out where 7 pi over 3 is. So, this is where it's nice to have the chart. I know from this that pi over 3 is 60 degrees. So I'm going to go through and I'm going to mark that's 1 pi over 3. This is 2. This is 3. This is 4. And I'm kind of counting by 60 degrees in my head because I know where they are. This is 5, this is 6, this is 7. So 7 pi over 3. Well, it lands and it has a reference angle of just pi over 3. Remember, that's the angle with the x-axis. So I'm going to go ahead and this is equal to what I do. I'm in this quadrant, so all of them are positive. So I know that it's positive. Put it in parentheses, tan of, so, oops, hold on, alright, so, I know that they're all positive, I know that it's in this quadrant, I know that my reference angle is pi over 3, so what I do is I just go and I take pi over 3, and that goes in right here, it replaces this 7 pi over 3, because you can clearly see that they land at the same thing. So I get pi over 3. And now I just go to my chart. Oops, undo, point. So I'm on the tan row. I go to pi over 3, which gives me root 3. And since this is positive, my answer is just whatever. I just pulled out of there, so it's just square root 3. And that's all for that one. So for C, I want to find the cosecant of negative pi over 2. So there's a couple things, and it doesn't really matter the order in which I do them. What I'm going to do is get it into one of the functions that I'm more familiar with. What I mean by that is I've got these three, right? Sine, cosine, tan. I know that that cosecant of something is equal to 1 over, well, everything has a cos, so that's sine of that something. Or I could write that as, so yeah, I'm going to leave it like that. So I know that since I have cosecant of negative pi over 2, I could just write that as 1 over sine of negative pi over 2. Now I'm not dealing with a function that I don't want to mess with. I can do sine at negative pi over 2 pretty easily. So this is one where it's kind of different. I don't have to use the chart for this one, although I could. Where's negative? I got to now figure out where that negative pi over 2 is, so that I can figure out what the sine is. So pi over 2 is 90 degrees. So negative pi over 2 is going to take me to this spot right here. So if I can think, I love thinking in terms of the unit circle when I'm doing these, because I feel like it makes it easier for me to see what's going on. So I'm there on the unit circle. Now, you should know that the x-coordinate on the unit circle is the cosine of whatever angle I'm at, and that the y-coordinate is the sine of whatever angle I'm at. So, since I'm down here, and the unit circle has a radius of 1, well, this thing is at 0, negative 1, which tells me that the sine of that negative pi over 2 is just this whole messy thing right here is just a negative 1. So this fraction is equal to a positive 1. That's this guy over this guy. So over -1, which just gives me a straight up -1. Now you may say to yourself, how does that involve all of this stuff here? Well, notice the places where sign are positive, quadrant 2 and quadrant 1. Sign is negative in this quadrant and this quadrant. And you may say, well, what quadrant does that count as? Well, since it's down in the middle of these two, in between these two, its sign is also going to be negative. Only cosine's positive here, only tan's positive here. There's no way that sine's going to magically pop to be positive and then become negative again here and here. The transition point from positive to negative is here, where I go like that or like that. Anyway, hope that helps.